And so we're very glad to have Chris Walters join us from CNH Industrial. Chris, I had breakfast with Chris, and he just mentioned that he had one of those really tough airplane journeys last night where he was stranded at the airport for many hours, and he only just made it in after midnight last night. So thanks, Chris, for persisting. We're very glad to have you here. By way of background, Chris leads the North America Regulatory Affairs team for engine emissions for CNH Industrial. In this role, he supports activities in the areas of state and federal regulatory development, alternative fuel projects, and strategic emissions programs. So he's been involved in many environmental-related initiatives and negotiations with governments around the world. And prior to that, he worked in engine product development, including application engineering and also engine emissions testing. So very well placed to tell us more about the perspective of from an engine manufacturer on emissions controls, and particularly some insights onto what that means for DEF. So Chris, thanks again for persisting and sticking through the journey, and we're very glad to have you here. Look forward to hearing what you have to tell us.
Okay, well, thanks. I had this great story to gain sympathy about my yeah, you stole my thunder, but yeah, I'm here. I'm very happy to be here. It's great to come out to the Phoenix area, of course. I live in Chicago. I think it's getting down in the 40s at night the last few nights, so although it was a little warm, I like the warm over the cold, so very good to be here. And what I'm going to really try to do is kind of segue off of the last presentation, which I think really was, talking about the market, framing the current market situation. I'm going to try to build on that and talk about some of the things that manufacturers are dealing with near term, long term, and hopefully from there you get a little bit insight about the trends of where we're going on some of the different areas like fuel and DEF and alternatives and new technologies that have been touched upon in the previous presentation. So what I always like to do when I give a speech is start with an outline, of course, and what I try to do, maybe that's a little unique here and I think helpful, is not just put the topics which may be convoluted, may not be clear exactly what my point will be, but I actually try to put the question that I'm going to try to answer for each of these items. So the market outlook, which is again going to be kind of building off of the last presentation, just giving a few facts that kind of frame up the rest of my presentation, but where do we sit from a manufacturer's perspective for on-highway and non-road? And then where will we go next? And a lot of that is driven by the regulatory outlook, and we'll talk through that both on-road and on-highway. We'll talk about trends for alternative fuels and electrification. I think the word electrification sometimes is a misnomer. I think the better terminology may be alternative propulsion methods, because it's not always electrification. There's other things. There's a whole gamut of novel concepts out there. At that point, I'm going to actually stop talking and show a video. It's sort of a shameless plug of our company's concept for a particular tractor, but I think it does a nice job of framing up sort of the mindset of where manufacturers are and what we're trying to explore to see what our customers may be interested in the future. Lastly, we'll try to bring it all together and talk about the impacts and the future, and just trying to give a directional indication of where DEF and fuel and alternatives are going in the future with all these current, past, current, and future considerations. The other, building very much on the last presentation, so we have sort of similar information to start off here. I'm trying to just put a very simple number to kind of get you guys framed, much like the last presentation, on what's still out there with the current generation, the current technology that manufacturers are producing on highway. So in the class 3 through 8, which was discussed in the last presentation, we're at that roughly 40% mark for the model year 2010 or newer, and as mentioned earlier, the EPA's regulations in that model year were the first to drive SCR technology, which obviously utilizes the DEF for controlling NOx emissions. This particular piece of information is more to sort of indicate that, yeah, there's still a lot of growth out there to get customers into new technology. The last presentation did a great job of framing up some of those obstacles. It's not just a methodical growth over time. There is also the used truck market. There is the regulatory impacts and pre-buy that could kind of come into play at certain points. So I just wanted to make sure that people understood that the market is not fully penetrated, and some of the reasons behind that have to do with many of the things discussed earlier, but from a manufacturer's perspective, we have, our customers are running commercial businesses, so they're going to do what's best for their business. And so, not many people are out there saying, I need lower emissions to feel good about my company's sustainability. It's more, I need to have a truck that's reliable. I need to have a truck that has good fuel economy, and things like that. So this number to me is a little bit slow, and I think those are some of the factors we've seen. The rollout was a little bit challenging. We had some quality issues, and those things have now started to shore up. But long story short is we still have some way to go on getting full market penetration of the latest and greatest emissions technology. This does not factor in the greenhouse gas emissions. We're going to talk about that more in the future regulatory outlook. The other thing, and I think this is somewhat interesting, it's not necessarily for you to be able to read this, because I wouldn't put this up there if I expected you to read all the words. This is a chart of every state's Class 8 market penetration. And really I want to show you is the average, which is that yellow line, and how the states are kind of going along that. This builds upon the previous presentation's comment about the number of miles traveled by Class 8. So this gives an indication about the fuel burn and the miles traveled and where we are as a market, a U.S. market. And really you see that it's pretty similar, although there are some states that are high and some states are low. Generally you're seeing that the fuel burn is kind of proportional to what that national average is for sales. So I believe that previous slide is somewhat indicative. I'm not a marketing person. We had the right person up here earlier to say whether this is a fair indication and a fair metric to use, but I think this just kind of shows you that we still are in sort of a moderate to intermediate step on evolving into a fully DEF reliant market and industry for the trucking industry. Now that's, although I may not have made it sound as simple as it really is, it's simpler than the non-road side. The non-road side is somewhat complicated because the standards for emissions are not the same for all power categories. So what I'm going to try to do is help you understand the last 8 or 9 years, very similar to what we were just showing on the on-highway side, talking about each of the different power categories that sort of drive different technology. So it needs a little bit of a decoder ring to understand this chart, but the gray boxes are basically indicating that no DEF is used in these categories, and then when you see the red pop in, that's the years where DEF was utilized. And if there's a gradient between gray and red, that means it was a possible technology choice but not mandatory to meet the standards. So really, I'll show the first two here, all the way up to 56 kilowatts. So this is a lot of your small construction equipment and small, we'll say, boutique farm tractors, very small stuff, mowers, things like that. They do not require the use of DEF, and they have no planned regulatory requirements to ever use DEF to meet the NOx emissions. Essentially what these products do is they have Tier 4 equivalent standards for PM, but in reality their NOx emissions are at Tier 3 levels. So they do not require after treatment to control NOx. This may be a surprise to some of you, but this is the way the industry is set up for non-road. On the on-highway side, standard's the same regardless of the power of the engine. So you have the same technology on the engines regardless of those classes of vehicles. For non-road though, the power of the engine is going to dictate whether it has the more stringent emission standards. Now when we finally get above 56 kilowatt, that's 75 horsepower, you're starting to see that we started to phase in Tier 4 in 2011. That's actually incorrect. I just realized I made a mistake. That 2011 box should be gray, not a big deal. The first year of Tier 4 interim was 2012, and showing the gradient there is manufacturers had the option to choose SCR as their solution, but not everyone chose SCR at that time. And then when you get to 2015, Tier 4 final kicked in this category, and then yes, DEF was mandatory. You have to meet Tier 4 final in this category on non-road, you need an SCR system, so DEF would be utilized. The reason I've striped those boxes for those last 4 years, or those first 4 years of Tier 4 final, is actually because manufacturers had provisions in the US to use previous tier engines at limited quantities. So you're really only going to see the full phase-in of Tier 4 final and essentially DEF compatibility in 2019 in this category. If we go to the next category, it's just shifted a year back. So started in 2011, and really you're starting to get the first full year of DEF usage in 2018. Above 560 is not a large population of machines, so you can see the numbers there. But in reality, the majority of the fuel burnt and population of high power vehicles is where, or the high power products in agricultural and construction are between 560 to, or 56 to 560 kilowatt. So I think that's part of the justification of why the lower engine, the smaller engines don't have as strict of standards. There's some other things that go into that that we won't dive into today, but really you're looking at DEF usage is a little bit different when you compare it to the on-highway space, because not all vehicles on the non-road side are actually required to use DEF. Sure. So 56 kilowatts is 75 horsepower, 130 is 175 horsepower, and 560 is 750 horsepower. Yep. So now on to where I make my living, if you will, regulatory space. For on-highway, I've tried to break this out to on-highway and non-road. I mean, although our company makes products in both categories, although the base technologies that we use for the engines are similar between on-highway and on-road, the regulatory landscape couldn't be different, in my opinion, at this point, especially here in North America. So the one thing I wanted to say is regulations are becoming increasingly burdensome for what we're gaining. I'm not up here to try to make a policy speech or compel you to agree with anything I have to say, but as we go along in some of the discussions we're having on the next round of emissions, we're starting to see that innovation is really being focused more and more towards just meeting the regulatory requirements that are out there and really coming on par with what the customer wants. And that makes us nervous, because as I mentioned earlier, what we're doing on the commercial goods side for this type of equipment and these vehicles is we're trying to deliver something that a customer is going to use to run their business. They're only going to come to us to buy product if we make a compelling business case to them, if you will. So spending a majority of our time worried about regulations is worrisome, but obviously we have to do it. It's our license to sell the product, essentially. So we do it, and we're happy we have a pretty good relationship with some of the regulatory agencies. Some of the relationships aren't as good as we'd like. So we usually come to a decent compromise at the end of what makes sense to protect the environment, but also allow us to sell our products and make sure our customers want to buy the product. The 2007 pre-buy that was mentioned earlier is sort of the lesson learned there, that we don't want that to happen again. Manufacturers don't want it to happen, regulators don't want it to happen again. So we need to be cautious and realize that this is the state of play right now. What I've tried to do is just give you a few takeaways here of really where the market's going. More stringent NOx emissions globally, but we're going to probably see the U.S. leading that charge, and mainly California. If there is interest in understanding sort of the latest state of play on that, I'm happy to give a little bit more info, but I'll save that for if somebody has a specific question. Driving us to emissions levels that are going to redefine the technology that's used in the aftertreatment design. So it's not just simply pouring more DEF into the exhaust to get to these lower levels. That could be part of it, but it's really about adding additional hardware to control the NOx emissions. And it's not always just simply converting NOx to harmless constituents. It's actually heating the exhaust to maintain the efficiency that we have today, things like that. So it's very difficult to go beyond the levels we're at today. Maybe we can catch 25, 30% lower standards than we have today without, we'll say, changing the paradigm of how the design of the engine is in the after treatment. But going much below that or further lower than that 25, 30%, you're talking about sort of a new piece of paper design of the after treatment system, along with additional base engine improvements. It's not easy, especially for the little bit we're gaining. And the other thing that we're trying to realize, the other thing we are realizing now is we test our engines in a test cell. If you're familiar at all with the Volkswagen situation that happened a couple years ago, that of course was on the light duty side. But the reality of that problem was a little bit different than what we're talking about with this third bullet, because they were purposefully cheating. Whereas today you may hear of a manufacturer on the heavy duty side having some third party or a university, somebody testing trucks, and their real world emissions are higher than maybe people anticipated. What people anticipated is sort of, and there's an asterisk next to that, because I don't know really I think everyone has a little bit different feel for what they anticipated would translate from a test cell to the real world. And so it doesn't mean you're cheating if your real world emissions are higher than expected, unless you're actually doing something that's violating the Clean Air Act or the regulations that are defined. So you could have higher emissions, but it may be because of the operation of the vehicle. It may be you operate in a situation where you have a lot of stop and go driving. It may be that you have a defect, a failure of a component that's not allowing you to, meet the emissions, and obviously that could potentially drive higher emissions. So what we're trying to look at as an industry is how do we do two things. One is make sure we right-size the perception of what manufacturers are doing to meet the requirements. If the regulators, I don't want to get too much up on my soapbox here, but I will kind of make one comment. The real-world emissions that we see from our vehicles is really dependent on how well the test procedures in the lab are defined by the regulators, not because a manufacturer is purposely gaming the system to operate in the real world differently than it should to meet the requirements. So it's sort of a nuance, but I think it's important to realize that it doesn't mean that you're cheating just because the real world emissions may be higher than anticipated by an NGO or environmental group, a regulator, the state of California, the EPA, whomever. So I think this industry has a really good track record of trying to work with regulators to solve problems. And one of the things we want to do is try to improve that real world emissions performance. So we want to focus more in the future on in-use testing. So let's test the trucks while they're in use out in the field. Let's stop worrying so much about meeting a standard in a test cell, because that doesn't translate very well to the real world. So we have a lot of concepts for that. It's going to take about 10 years to get to. It's probably not of great importance here, but it's in great importance to me, and it's really a paradigm shift that we're looking to take as an industry. Get away from test cells as the method of compliance and look at balancing that out with more real-world emissions, which obviously is what we're all trying to get to. California is driving this one pretty hard right now, looking at longer durability requirements for emissions components. So the way it works today, basically manufacturers on the hook to provide a warranty for the first part of the life of the engine for all on-highway and non-road products. They want to drive that further. They want to really extend it like 2 or 3 times longer durability and warranty periods than we have today. So that's a big cost component for manufacturers. So that all of this, although it may not be terribly relevant to you guys in the sense of how does it affect DEF usage in the engines, but it does affect the cost of the product. So these are going to be relevant to the customer at the end of the day. And on top of that, as was mentioned in the previous presentation, we also have to just, take care of those pesky GHG standards that are coming along in the next decade. So all of this is going to be layered on top of existing standards that are coming into the future. In the future, you saw 2021, 24, 27, 3 different steps for that. All the bullet points above that are things that they're actually looking to put in place in the middle of all of that 2021 to 27 timeframe. So it's daunting, and that's why I point you back to the first bullet point there, is it's really becoming a big part of what we're doing. It always has been, but now it's becoming even bigger. Now, if we switch to the non-road side, a lot less certainty. We're not sure what's going to happen. There could be nothing that happens. There could be something where we align with the most stringent standards that exist in the world, which now are being deployed in Europe. Non-road today, you can meet the standards in all those categories we talked about that have DEF, the 56 to 560 ranges. Those can be met with SCR, but also without a DPF. And regulators don't like that. They want diesel engines to have DPFs. So there's a new standard in Europe that's coming into play next year and the following year, where they will force everyone to have a DPF. The same standards essentially as what we have in the US, they just have another criteria that requires you to install a DPF in addition. So we could see something that aligns to that. Whether that happens in the US, the political landscape is skewed a little bit away from that being something that we can count on, but I won't say that that's a closed book. I do think it's possible. I think the perception that the current administration in the White House is completely against regulating industry is not necessarily 100% accurate. It's probably generally the right way to look at it, but it doesn't mean it's not going to happen. I think you could see something happening very soon on the on-highway side, and whether we see something come along with the non-road side is less certain and probably unlikely, but this would be the most likely step that industry would support, is an alignment with Europe. That would not change the DEF outlook, essentially, if this sort of standard came into play. The in-use thing, really more for me to worry about than you, but very similar to what I talked about on the last slide. The real interesting thing for everyone in this room to consider is if NOx limits for engines, especially those below that 75 horsepower range, the 56 kilowatts, could be a step. And there's some research going on out there. CARB's interested in what's the potential. Really one of the limitations that we have in this area is the constraint of installing after treatment on small equipment like skid steer loaders, and even you think of mini excavators, sort of the product that I always think of. It's no problem when the excavator is of a certain size, but these excavators keep getting smaller and smaller for urban construction sites like digging up a sidewalk and things like that. To install a DPF and an SCR tank and DEF lines and all that sort of equipment is something that we've tried to stay away from. There's also the consideration of how much contribution to the overall emissions inventory is coming from this category of engines. There's also some regulatory hurdles that would need to be overcome in California. They're not allowed to regulate products below 175 kilowatt for non-road. So this would obviously fall into that. So the preemption in the Clean Air Act would not allow them to regulate it on their own. So they really would need EPA or come up with some very clever regulatory program, voluntary or otherwise, to sort of figure out something in this power range. So, but this is probably something that's more likely 10 years from now than 5 years from now. I think the diesel particulate filter step is probably in the next 5 years. And then NOx could be something that kind of comes as a second step after that. Maybe the takeaway for you guys is we're not done regulating engines, not even on the non-road side. I mean, it's if your job is to regulate, are you going to eventually just say, we're done regulating? No, you're going to keep your job and you're going to keep going. But, you know, it keeps people like me in business at least. So we, again, have a pretty good relationship on the non-road side with regulators, and I think they understand some of the complexities we have. At the end of the day, though, we could be seeing stuff eventually that aligns us with Europe, and then if Europe looks at lower NOx standards in 2021, the EPA is run by a different administration in the White House 5 years from now. You could see, you know, things ramp up on the non-road side. GHG, I'll touch briefly. Really hard to do for non-road. GHG for on-highway is driven, especially in the phase 2 standards that are going to come in starting in 21, really by vehicle improvements. There is an engine component to it, and you can set a CO2 standard, which basically would be the greenhouse gas contributor from a diesel engine. But there's no way to do aerodynamics on non-road. You can't put aerodynamic improvements into a tractor or combine. So we could set a CO2 standard for engines, and I mean, I think that's reasonable, but you're not going to see substantial improvements. The target for GHG phase 2 is 40% improvement in greenhouse gas, or reduction in greenhouse gas. 20% of that comes from the engine, the rest is vehicle-based. New, more efficient transmissions, low rolling resistance tires, aerodynamics, all sorts of stuff. On highway, or non-road, translate that over to non-road, barely any of it's applicable. So you're looking at not gaining a whole lot on GHG from non-road. Unless you want to start eliminating combustion engines, that's a whole nother story. But that's a pretty good segue to my next slide. So what I want to do now is sort of show, it's a, as I said, shameless plug of our company's concept for a tractor that uses biomethane. So taking, it's really the essence of setting up a whole system at a dairy farm that uses waste, converts it into electricity for the farm, converts it into liquid or compressed natural gas for the tractors that operate on the farm, and so on and so forth. So this is a really nice 2-minute clip. You get to take a break from listening to me and get to see something a little more exciting here. So let's take a look.